This video is an introduction to infrared or IR spectroscopy. Let's begin with a refresher of infrared radiation. In general chemistry, you learned about the electromagnetic radiation spectrum. Infrared radiation falls on the low energy end of the spectrum, meaning that infrared radiation has very long wavelengths and it also has low frequency. It's nice and slow. And this means infrared radiation is safe for humans. In infrared radiation, when it interacts with a molecule, it causes the bonds in a molecule to stretch and bend. Let's make a note of that. It causes the bonds to stretch and bend. So this means that whenever infrared radiation interacts with a molecule, the molecule's bonds begin to stretch and bend. Let's kind of draw some pictures of what this might look like. Let's say that we have a water molecule and we blast that water molecule with some IR. So there's a variety of different ways in which the bonds in this water molecule can respond to the infrared radiation. One might be that the bonds, the oxygen-hydrogen bonds, stretch out. So that just literally would make the bonds get longer. This would be stretching those bonds. Or another option would be that the bonds get smooshed closer together. So they're just kind of compressing a little bit. And the bonds don't have to stretch and bend symmetrically, like they don't both have to get longer or both get smooshed shorter. So maybe we might have one bond that gets really stretched out while the other bond stays the same, or maybe it gets kind of compressed, so we could have sort of an asymmetrical thing going on. In addition to that, the bonds can bend, so this could affect the bond angle of the oxygen-hydrogen-oxygen bond. We could see that those bonds maybe would come closer together, or maybe they would move further apart. So maybe we might see, let's kind of try to draw them coming closer together, squishing like that. Or maybe we could draw them further apart, like that. So all different types of motions are taking place as infrared radiation is interacting with any molecule. Water is an easy one to draw because it's small, but for all molecules, when infrared radiation interacts with the bonds begin to stretch, compress, bend, and do all kinds of different movements. Infrared spectroscopy is a type of analysis that allows us to measure the wavelengths of infrared that are being absorbed by a molecule, causing that molecule to undergo all of these different types of stretches or bends. So spectroscopy, infrared spectroscopy, measures, we're going to call it the type of IR that causes stretching and bending. Stretching. Now it's kind of funny to think about the type of IR, what type of IR is causing stretching and bending, because in general we think about IR to just be itself. There is only one type of IR, and it is IR. But remember, within the visible spectrum, we have many different types of visible light. We have purple light, we have blue, we have red light, we have all the different colors. And so within the visible spectrum, we can acknowledge that there are different types of visible light because we can literally see the different colors with our eyes. And the same is true for infrared radiation as well. Along the series or the spectrum of wavelengths that are associated with IR, every wavelength is a different type of IR. And so infrared spectroscopy, we are measuring specifically the exact type, the exact wavelength, or the exact frequency of radiation that's associated with each one of these different types of movements. Infrared spectroscopy is done using a machine called an infrared spectrometer. This is a picture of an infrared spectrometer. This is the exact infrared spectrometer that we use at my institution. It's very small. It is maybe it's about 1.5 feet, maybe it's 2 feet long, maybe it's about 1 foot high. It's not very big. And on this surface right here, this sort of metal disc that you can see, this is where you place your sample that you'd like to measure. And the amount of sample that you need to measure an infrared spectrum is literally, it's about as big as that dot that I made. So it takes a very, very tiny amount of substance. And you just set it right there. This machine is connected to a computer. That the computer runs the machine and then it displays the results on the computer screen. The results of an infrared analysis is called an infrared spectrum. And here is a picture of an infrared spectrum that I downloaded from NIST. Here is their webpage if you want to go check it out. This is the infrared spectrum of 1-hexanol. And this is just an idea of what the data looks like that you get from an infrared spectrum. We can use this infrared spectrum to give us a lot of information about the molecule, specifically the types of bonds that are in the molecule. For example, is there an OH bond? Is there a CO bond? We can also use infrared spectrums to just purely identify molecules. Every single molecule has a unique infrared spectrum. It's kind of like every person has a unique fingerprint. And so if we are measuring the infrared spectrum of a molecule, we can compare it to a database full of spectra. And typically an automated database will be able to identify the substances by their spectrum alone. In the next few videos, however, I'm going to be teaching you how to analyze the different features of the infrared spectrum so that you don't need to rely on a database in order to interpret the results.